Hi, welcome to part 3 of the video series about vertical projectile motion. In the previous video, we had learned about the equations which will be used most in this topic. In the future videos, we are going to solve many examples to see these equations in action. But before that, we will learn some tips to keep in mind. As we learned in the first video, all free-falling bodies have the same acceleration due to gravity. On the surface of the Earth, this acceleration is 9.8 meters per second square and its direction is downwards. This is one of the statements we forgot or confused most while solving the exam questions. Let's imagine an object thrown up. It is not important that the object moves upwards. Once it's launched, the only force acting on it is the force of gravity. So, the acceleration of the object is 9.8 meters per second squared downwards. Even though, just for a moment, the object has zero velocity at the maximum height, it is still experiencing the gravitational force. Therefore, the acceleration is still 9.8 meters per second squared and it is still downwards. Afterwards, again, due to the influence of gravitational force, the object starts to accelerate in the downwards direction with a magnitude of 9.8 meters per second square. In this topic, most of the quantities we have to calculate are vector quantities, which have both magnitude and direction. Thus, it is important to choose the direction wisely. Even though there is no specific rule in doing so, choosing the direction of initial velocity as the positive direction will make calculations relatively easier. In the questions where an object is thrown up, upwards should be chosen as a positive direction. In this case, initial velocity will have positive value and acceleration will have a negative value. On the contrary, if the object is thrown downwards or released from a certain height, choosing downwards as positive will be a better decision. Doing so will result in both initial velocity and acceleration getting a positive value. Another point to remember is that if an object is thrown up, at the maximum height, velocity of the object is equal to 0. Fourth important point is that the time intervals during the upwards motion and the downward motion are the same. Let's consider points A, C, and E. Points A and E are at the ground level and C is the maximum height the object can reach. It takes delta TAC for the object to reach the maximum height and delta TCE to fall to the initial point. These time intervals are equal to each other. Let's add another 2 points on the diagram, points B and D, which are at the same height from the ground level. Being at the same height is crucial for the statement to follow. It takes delta TBC to move from point B to point C and delta TCD to move from point C to point D. These time intervals are equal as well. But once more, take note that the heights of B and D must be the same. Finally, let's consider the times required for the object to reach from point A to point B, as well as from point D to point E. We can easily say that these timings are equal to each other too. Once more, we must make sure that both A and E are at the same level from a reference point as well as B and D. The last item to remember is that the magnitude of the velocity at the same point on the upward and downward motion will be the same, only the direction will be reversed. Magnitude of the velocity of the ball at point A is equal to the magnitude of the velocity at point E, but their directions are opposite to each other. We can state the same statement for the velocities at point B and D as well, as these two are at the same height from the reference point, which is usually considered as the ground level. In this video, we learned about 5 points to keep in mind while solving the questions in this topic. In the next few videos, we are going to solve some examples to see all this knowledge in action. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.